Assalamu alaikum, everyone. Welcome, Mr. Muwaffaq Thiabi and everyone. We will start our workshop and hopefully others will join later on. I am Dr. Amir Al-Ghanem, Assistant Professor at PSU under the Department of Computer Science. So today's workshop will be presented by Mr. Muwaffaq Thiabi, and he is a developer at IBM. He's interested in cloud, DevOps, and containers, serverless. And he loves the big development and innovations and open sources and collaborations. His workshop today is going to be about exploring AI using cases. Welcome with me, please, Mr. Muwaffaq, and the floor is yours. After the attendance, after half of the time, I will put it on the chat. And if you have any questions, please put your questions on the chat box. So thank you, Mr. Muwaffaq. You can start now.
Thank you so much for the introductions. Hi, everybody. Thank you so much, everyone, for joining with us today. So I just need help with a doctor with how to share my screen. I don't know. I'm looking at, okay, present now, maybe?
Yeah, present now. Then share your entire screen.
Got it. Let me just allow entire screen. Alrighty. It says record the computer screen. It's okay, maybe no. Oh, wait, let's try again.
Does it work, or do you need help?
Yes, I put it. I just allow to share my entire screen, and it says just message pops up saying can't share your screen. I don't know. Let me check my prefixes. Wait. Go there.
Maybe you can go to the settings, then host controllers, share the screen, and turn it on, please.
Window maybe. Touch screen. Oh. I don't like this. Let me try again. Never done a conference in Google.
Okay. I will share my own to show you the settings, and hopefully
please,
it's going to help. Okay, no problem. Okay. So can you see my screen? I cannot hear you. I think your speaker is, yeah.
Yes, I can.
Yeah, you just need to go here. You are present now. Then you see three options. Share the entire screen. If it's not working, go here to the three dots and make sure that the settings that you can share here. Share the screen. So turn it on. Then you can share the screen with us. Okay.
How about the setting? I don't have the host controls. I have auto, I have video, but I don't have the host controls. Like
okay.
the last. That's
okay.
the case.
Okay, let me check again and see if I can enable it. Just 1 minute, please.
Sure. Sorry about that. We are just in about to share the screen now, and then we'll be ready to start.
Assalamu alaikum. Hello, Mr. Mufak.
وعليكم السلام. أهلا يا هند.
Yes, you're not able to share your screen.
Yes, that's right.
Um, did you click on present now?
Yes, I clicked on present now, and there's two options to select. You
Yes.
can choose your entire screen or a window. So I choose your, and then I pick on that one, and then just there's a message pops up saying cannot share your screen.
That's it. You just can't share your screen. That's the message.
Yeah, and then it says you must grant permission in order to screen share. I
Okay.
think you need to transfer
Okay.
something else.
Let me enter as an admin. I'll make you the host.
Okay.
Hello.
Hello.
Yes, please. 1 minute, and I'll be sharing with you a new link, so you will be directed there. And here I will paste the link, so whoever can join the meeting will be directed to the second meeting. We will be using Zoom platform instead of the Google Meet.
Okay. Thank you, Ms. Henry.
Muafaq, I was wondering if you can send me your presentation and I can present it from here. I don't know if that would solve the problem.
You can share your screen, Majda? Is that okay?
Let me try to share it right now, see if it works. Okay.
But I have hands-on, I have other resources. I need to share my home
Yeah,
screen.
you're right. Okay. So, Muafaq,
Well, you guys cannot solve the problem? I don't know.
So Ms. Hind is going to send us another link. Then we're going to rejoin to the other link. And inshallah, everything is going to work fine.
How about if I can rejoin again, maybe?
yes, please try because
Yes,
let me
please try if you can rejoin, because I'm not able to change anything from the settings.
yes,
It's from your side.
Sure.
please join using the link that I sent you, Muafaq.
All right. I'll be back.
Sure. Dr. Amira?
Yes, Hind?
I pasted the link in the chat section, please, because I need to go to another workshop. You can switch to Plan B, which is using the Zoom platform. Here is the link. Please make sure all the audience are directed there in case Mr. Mufaq is not able to share his screen again. Okay?
Okay, no problem. Thank you.
Thank you so much. Thank you.
Great, it's working now.
Muafaq, you're on mute if you're trying to say anything.
Yeah. Mr. Muafaq.
Hello?
Okay, thank you. Great, it's working now. So good luck. Thank you.
Hello?
Yes, we can hear
Audience.
you. Yeah, we can
I
hear
may
you.
have you audience. Do you guys see my screen?
Yes, we
Please
can see
write it
it.
in the chat. Write it in the chat. Woo! That's awesome. Wow, we solved the problem. Here we go. Alrighty, so let's get started. I'm sorry about the delay, and yes, sorry about that. Let me see. Do you guys hear my voice? I just want to test that. Do you guys hear my voice? Yeah, of
Yes,
course.
it's clear. Yes.
Just want to make sure. Yes. Awesome. So let's get started. All right, everybody. Thank you so much, everyone, for joining with us today for the workshop that we are going to cover, explore industry AI use cases. So my name is Muafaq Diaby. I am a developer. I work with IBM, Riyadh based, and this is my Twitter. This is my LinkedIn. Please follow me. If you have any question, this is also my email. Please, you can contact me anytime. So today we are going to have a really like a very heavy package that it has different industries and different use cases in different industries. And we will be talking about some use cases in healthcare industry, medical industry, and then we will have some use cases in transportation industry. And also we will have hands-on lab on how to deploy AI deep learning computer visions object detections app. It's already built. It's already developed with Pythons, used with a Tensorflow, and it's already built in a Docker and published publicly in a Docker Hub. So we're just gonna have to take the image, and then we're just gonna deploy it using Kubernetes and Openshift technology. I hope you guys are familiar with the containers technology, because it's very important concepts for the digital transformation for the future. And so I'll be talking about Openshift. I'll be talking about Kubernetes and containers. Also, I will have some, so the agenda basically, we will have data science. We will have basic concepts about data science. And then we will be talking about some of the methodology in data science. And then we will talking about computer visions and basic concepts about computer visions. And then I will introduce IBM Watson in data and AI specifically. And then we will share with you some of the transportation industry use cases. And then we will have some of the projects I personally worked on in healthcare industry. I would like to share that with you, exploring open source use cases. And then finally, we're gonna have really, really fun hands-on, and we're gonna have a really great time to work on that together. So, first of all, I would like to ask you please to sign up with IBM Cloud. So if you go to that link, you go to ibm.biz Prince Sultan University, PSU, explore AI use cases. It will navigate you. Let me go ahead and do that. Because I already logged in. So basically, you just need to fill your information, and then you will receive an email for confirmation, and then just confirm your email, and then you will be ready to access to the cloud. You will have a $200 credit to use the IBM Cloud services. You know, any services around the blockchain, services around data and AI, services around security, around containers. There are a lot of services. I will walk you through the IBM Cloud in the catalog, and I will show you how you can navigate to the services and how you can see the services. So please do this. And because you need to assign to IBM Cloud, so you can assign to the lab. The lab, I already requested for you guys for 24 hours only, and it will be expired. Openshift cluster. The Openshift cluster is really, really expensive, and it costs. So I have to request it from IBM in the US, so they can allow me for 24 hours for the workshop. So I already requested for you guys. So please, guys, go ahead and try it. You have only 24 hours. Try it, play with it. And in order to access to this lab, you need to log in with the IBM. You need to have an account with IBM because you need the ID. Let me go back to the slides. As you can see, you need the ID after you assign with IBM. You need to put your email as your IBM ID, and then you need to put the key. I already shared the link with you in the chat. The key is basically OS Lab, and then just hit agree. And then you will receive this window, and then just log into this IBM Cloud. Just click on that, and this is basically the link. I already shared it with you guys on the chat. And then you will navigate to the platforms where you can see, in the dashboard you will see the clusters, and then this is where you can see the Openshift. You need to click on that cluster Openshift, and then this is the window where you can see the Openshift cluster. Then you need to click on the blue button right there on the right side. Just click on that, Openshift Web Console. And then that's what we need to have, the Openshift Web Console. So I'll be talking about Openshift, but let's just start talking about some of the main concepts in data science. So basically now when we look at each umbrella, when we think about the deep learning, which is a specific set of machine learning algorithms, and to do the deep learning, you have to have machine learning, which is to identify pattern in data. and AI, which is application of data science, and data science, which is the big umbrella of the science of handling data. Every single AI applications associated with the data, and data is so important. So the methodology basically for application development and for the workflow, the process when you want to develop an AI applications, especially in data science. So you start with the start point, right? And then you start with the business understanding. What is the business goal? You need to define the gap. You need to define the idea. What is the business target? And then you need to do some gap analysis. You need to know what is the idea, the research area, the research topic. So once you have an idea of what you're trying to develop, then it comes to the data. The data always challenging to collect the data. Collecting the data, it's very challenging. You have an idea, but you need the data. It's hard. I'll be talking about some of the challenges that you're gonna face when you want to collect the data. The second stage starts with the data processing, and the data processing, which is one of the main in the data processes is the data collections. And now it comes to, look, imagine that there is no any data in the world. It's clean for you. You have to do some cleaning and analyze it. You have to do the cleaning and analyzing parts. So cleaning and analyzing, it's very important. And I will share with you one of the projects that I've been working on and how important to do the cleaning and analyzing the data before you start building your model or you're training your model to the machine. And then it comes to the building model. Once you clean your data and you analyze the data and you know the key values and you map the key values, after analyzing and merging and mapping the key values in the data, you know the target in the data, and the data is already clean for you, then you start building the model. And then you train the model to the machine. And then you test the model. And maybe the result when you test the model, it's not the way you like it, or it's not the way you expect it. So then maybe it goes to the building. You go back to the building models, and you go from the process again. And then maybe the testing model, it's the result, its accuracy is very good for you. Then it starts with the evaluations, the evaluate model, and then the evaluation also sometimes contain of two process, which is between building model and data processing to compare the evaluation. And then finally, the business outcomes, and then which is if the business outcomes meet the requirements as expected in a business understanding. And then finally, the deployment. You need to deploy your applications on the cloud with the Amazon, with the Google, Microsoft, IBM. So you need to take advantage of and understand the cloud computing and the deployment. And then finally, maintaining. So AI everywhere, influencing everything we do. Netflix, there's a lot of AIs. If you watch comedy actions, Netflix knows your characteristics. Also, self-driving, Uber Eats was providers. AI, it's everywhere. And but all based on data. So AI applications is based in the data. So the data is important. So the challenges for the data, how long does it take you to find the data sets you want? 2.5 hours per day? Maybe it takes you 1 week, 2 weeks, a month, 2 months to find the data? It's hard, right? I face this really. I have an idea, I have projects, but I face a challenge to find the data I want. Sometimes I want images. I cannot find it. It's hard. Sometimes I need the Excel sheets. Sometimes I need the text. It's very hard. So sorry about that. Kaggle is the great place to find the data sets. And I am personally recommending this for you guys because it's very, very amazing place where you can find the data sets. In any industries, you can find a lot of competitions, basically. A lot of competitions. They post the data and they put a competition for the data, looking for developers and software engineers to show their skills on the data. There's a lot of data in healthcare, transportation, financial industries. So you can find all the data you want in the Kaggle. So I think Google datasets also, it's a good place to find the data, but Kaggle is really popular. It's really famous place to find the data. So there is a lot of so we're not going to talk a lot about Python today. So what type of the data? So we have voice, images, or text, or maybe we have a business data. So today what we're going to show you, how to automate business data with automation AI, Auto AI, IBM Auto AI. And try to imagine the story of any businesses or any organizations when they have a data, a history, for example, let's say a hospital, a history for patients for the last 10 years. So the hospitals spend millions to looking for to make a sense of the patient history, right? They want to understand the business. They want to understand the data sets for the patient entry, and also, like for example, customer data sets. The customer data sets, the history of customers. So they spend millions on this data. They're looking to analyze and visualize and make sense of the data. And think about the process of doing this work in terms of working with the Pythons, which is one of the famous in the data science. How long does it take you to develop or to code or to software with the data science to do your work, to analyze, to do the visualization part, to make a picture of the data? It takes you a month, 3 months, 4 months, and it's too hard, right? So IBM software is already developed within a lot of features and methodology to use, and it uses machine learning. We'll show you that, and then we'll talk about some of the feature and advantage in IBM Automation AI. So before we jump to the demo, which is the first demo that I'm going to be, I will focus on the business data sets. We have customers, telecommunication industry. We have data sets for customers, history of customers, and we will try to make a classifications using this data. Using this data, we will work with the IBM Automation AI. So we will automate the business data sets. So IBM Services, so Watson Services, we have empathy, we have visions, speech, discovery, language, assistance. So Watson Assistance, which is one of the famous in the market today, to make a chatbot, NLP, natural language processing. We also have Watson Discovery, which is machine learning, which is a platform powered by machine learning to feed for the data. We have like tool analyzers, personal insights, visual, natural language understanding, and then Knowledge Studio. I'm not going to really talk about all of them. So today, my use cases I have for you, it cover about visual recognition service. We are going to have computer visions projects use case, and then we have Watson Assistance and Watson Discovery, 2 APIs integrated in one project, in one use case. So you can call this APIs because it's all services on the cloud, right? And each service does different things, right? So I have 2 APIs integrated in my application, which is Watson Assistance and Watson Discovery. And the reason why I have Watson Discovery with Watson Assistance is because I have a data sets, which is open source data sets, and it's a huge amount of data sets. I need to have cloud discovery to to feed and to train the machine on this huge data sets. I will be talking about the use case in the healthcare industry in the upcoming slides. So we'll be talking about that. So I will try to talk about Watson Assistant, Watson Discovery, and visual recognitions. And then, yeah, that's all. So I'm not going to really touch the other services, so I can't really talk about all of them. OK, so automate business data with O2 AI. So that's basically where we're going to show. So I did this demo, and I recorded because I'm not going to do it in a live. We are going to do something different in a live. So this is just to show you on how to apply, basically automate. Well, before we show you that, let me share with you the data sets. We'll talk about the data sets first of all. So this is the data sets. History of telecommunication customers. It's the big data sets. This is like, we call it business data sets, right? So the customers, they spend millions on this data sets looking to make a sense of it, or trying to map a value, or visualize it, make a sense of this data. So this is when it comes to visualizations and analyzing parts. And and sometimes we do, and it works with, there's also Cloud Foundry, but we're not going to talk about Cloud Foundry. So basically what we're going to do in this data sets, we are going to look at the last columns, and we're going to make classification, yes or no. Basically, yes or no, who's going to stay with the company, and who's going to, this is like a data set about employers in the company, So the churn columns, we have yes, no, which is very good to make a classification on this on this column, just for a demo, So we are going to make a classification on yes or no, who's going to stay in the company and who's going to leave the company. We're just going to do classification part, okay? So this is the data sets. You can find the data sets on, if you go, I already shared with you in the chat, the lab, I think lab 2. If you go to the lab 2, you will see, if just scroll down, you can see the data sets. It's already attached on the website. Alrighty, let's go back to, oh yeah, the video. Forget about it. What is my video? Right there. Okay. So basically, once you log into IBM Cloud, you can see the dashboard. You can navigate to the dashboard and then just go to the catalog, and then just search for something that's called Watson Studio, which is it's like environment, merge all IBM services together. So just updating my accounts. So you go to the catalog, right? And then you search for Watson Studio. I already have an account, an existing service, so I have not created one. So I just viewed the existing service. So maybe you can create a new service. You can choose what is the data center that you want to, like Washington or London or anywhere in the UK. And then once you go to the Watson Studio, Watson Studio, it's already provisioned on something it's called Cloud Pak for Data. Cloud Pak for Data it has a different story, but we're not going to talk. It's architect and running on Openshift, and it merged all the cloud machine learning and AI, data and AI services to merge all on Cloud Pak for Data, which is all the services now it's running on Openshift. So we just, create the projects, call the projects, and make sure that, let me just go back. You have a cloud object storage, because that's where you can storage, that's where you can, it's going to be cloud object storage. It's going to be like a database. You're going to store your data into that cloud object storage. So you need to have cloud object storage. How to find cloud object storage? Let me just go back. You need to go to the catalog and just search for cloud object storage. this one, cloud object storage. Okay, just enable it. And then you will have to add the data, which is you navigate to the assets, and then add in the data. And then once you add the data, this is the cool part, is basically you can add the projects on the data. Let's suppose that you have images and you want to apply the machine learning algorithms on like, for example, you are trying to do object detections or classifications on images. Then that's where you have the free to choose any surfaces, for example, visual recognitions surface. Or you can, if you want to open Jupyter Notebook, you can also open Jupyter Notebooks on your data, and you can do some coding if you like. Also, Cloud Foundry, which is a place where you can analyze the data. But in my case, we're just going to use Auto AI experiment on the data sets. So I will have to choose the Auto AI experiment. And then you need to associate the Watson machine learning service with your projects. So as you can see that you will have a link to click on, and then you can enable. If you don't have Watson machine learning, then you can provision a new one. And then select from the projects, and then you select the data sets, and then you select the column that you want to make a prediction on. What do you want to predict? And then we are going to deal with the binary classifications. So, and the positive class is going to be yes, and accuracy. This is where you can see the configurations on the automation AI, where you can, if you want to do, change the configuration. I kept it as a default. So select feature to include. If you don't want to include all the columns to be selected in the machine learning, so you can, uncheck them. Optimize metrics. You have or recall precisions, average precisions, log loss, algorithms to include. There are type of algorithms to include. So if you don't want decision tree classified or whatever logistic recognition, you don't want to check them, that's fine. But I just kept it as a default. Now we have algorithms to use. If you choose 2 algorithms, you have 8 pipelines, and so I kept it as a 2. And this is just showing the experiment details on time. And, so now just run the experiment on, and now we have submitted the data to Watson machine learning. So it will take time, but let me just try to accelerate this. Oops, no, go back. Okay, stop. 25. And then, and now it's starting with the generating the pipelines. We have 8 pipelines to complete the process of the training. I want to show you the other graph. I don't know if I did. No, I think so. Yeah, this one. So basically, this is the process. Read the dataset, start with the reading the dataset and split hold-out data, and then read the training data, and then pre-processing, and then model selections, and it goes through 4 different things. The EXGB classified, and then hyperparameters optimizations, feature engineering, and then hyperparameter optimizations. And there are we have 2 algorithms to use, and each single algorithms use 4 pipelines, and it goes as it increases. Now the best, I think the best pipelines is, I think, pipeline number 4. It depends on the accuracy. I'm not gonna really try to explain in details what is everything, because we're just gonna try to give the high levels on the development session, because we have a lot of other stuff to talk about. So let me try to isolate this. So the process will be finished soon. Okay, I think soon. Let's go a little bit. Yeah, pipeline 4 is the best models, and now you can see the curve. The model accuracy is 0.8, and you can see the model evaluation measures, recall, precisions, all the algorithms that you choose to, and then just there is a confusion matrix where you can see the observe and the redirected, and how much being less correct and how more correct, represented by colors. Really cool stuff. And then we can look at the precision recall curve. And then we can see the model information as well. The column that you did the classification on, numbers, features, number of evaluation instance, and then feature transformations. There are a lot of new features generated by Watson machine learning. I think it was almost like 14 new features, which is learn. The new features generated, and this is how the machine learning, it learns from the new features. And it's generated by the machine itself, not from the data. And then there's important feature importance, where you can see the accuracy for each columns in the data, including the new features. There are some new features which is generated from the machine itself. And that's it. If you want to deploy, yeah, this is where you can see the model name, the accuracy, blah, blah. And then if you want to deploy, basically, it's very simple. You just need to save the model. How to save the model? Well, let me just show you how to save the model. Yeah, you click on Save As. Did I save it? No. Okay, wait. How to save the model? Okay. So we see the feature importance. So you click on the Save As, I guess, and then you can save the model as a notebook if you want the code, or you can save it as a model. If you want to have the code, you can have the code externally, and then you can run it externally, like in your own Jupyter notebook. You can run it, but you need to have the APIs calls. You need to call the IBM services in your code. And then, yeah, that's all I want to say. But if you want to deploy the models inside the Auto AI, you just need to save it as a models, and then you just need to click on it. And once you click on it, okay, click on that, yeah, click on it. And then promote to deployment space. And it will direct you to the deployment space, which will direct you to Cloud Pak for Data. Cloud Pak for Data, which is architect and running on Openshift. And that's how it's processed. So that's all I have for you for the how to apply. Basically, if you go to, I think the hands-on, I think right there. Yep. If you go to the hands-on that I just shared with you in the chat, it has a lot of details explained. It's really documented. Just go through it, do some reading. I believe that you will enjoy it. All right, let's go to computer visions, one of my best area. All right, so now comparing to our eyes as a humans and comparing to the camera visions. So how far can we see in a distance, using the human eyes, or how far can we feel the environment around us, right? So now digitals like cameras or sensors can see and feel in distance, and it uses AI softwares, and everywhere in the streets in the city, sensors, cameras, and it can see far in distance, much better than us, and that's what I'm going to share with you some of the use cases about computer visions. So basically, the computer vision's first photographs came in early, 1860. That's when it was 100 years ago, before I born. So how do we now? When we look at these pictures, how we can recognize it, right? We can recognize it. We can understand the pictures. Well, this picture is a flower, and because it has a contents, it has a colors, and it has a features, right? We can understand these pictures using our eyes, right? But the computer can see a picture like this, right? The computer just only can be represented as a numbers, as a pixels, and those numbers are represent as a colors, as a features and contents. Deep learning, just very quick about deep learning. Deep learning, I think came in 2000s, maybe 30 years ago. I'm not sure, but deep learning is a subset of machine learning. Deep learning built on top of neuros. Each neuros consists of input, hiddens, and outputs. Deep learning can be called computer brains, and it does the same functions of the human brain by making decisions, And deep learning can learn from data, unstructured or enabled data. And that's one of the famous, which is convolutional neural networks, one of the famous class in deep learning. Now it comes to the Tensorflow, which is the Python application that we have today for the demo, which is already built and developed with the Tensorflow. Tensorflow, which is really one of the famous frameworks in Python today, and it's such an amazing framework. So Python is a set of data, flow graphs to build models. It always it allows developer to create large-scale neural networks with many layers. So today we are going, and then what's the difference between classifications and object detections? Object detections, now, there are so many AI applications today in businesses use object detections. Object detections, basically, the meaning behind object detection is that open has the ability to recognize more details in one single image. Think about it. It's objects in one single image. And classification, just making decision by yes or no. All right, transportation use case. What do we have in transportation? We got some for you this video, and to show you how we can use the digital camera to how to watch in distance and to detect the speeding cars and that's amazing. And that's how we can benefits from AI in businesses and economics. And that's, I think it's in Saudi Arabia. And that's how we can use object detections to detect the speeding. And it can feel, the camera can feel with the sensors and can make detections and watch in a distance and can do a great job for us. Oh, let me go back. Did you guys see the video? I think so. Yeah. I don't know if you guys can see the video, but I don't know if there's any voice, any audio.
We can see the video, yes.
Let me check the chat. What is the chat? I think we are in here. No, we are in Google Chrome. Let's go. Do you guys have any questions? I'm looking at. Okay, we're good. All right, so let's go to the second use case. Okay, we moved it. All right, so the second use case, one of the amazing projects last year I worked on, and was so, I really enjoyed it. I was collaborating with the developer in Middle East and African, some developers in Dubai and in Pakistan. So we worked together on that project. It was amazing. It was amazing contributions on open source projects. So basically, the project is when the pandemic started in March last year. There was a spread, Kaggle spread data and its resources over 400,000 Scholar articles about COVID and other viruses like SARS and other coronaviruses. And it's a huge amount of articles. But the articles really provided in a JSON format. You can see that 35 gigabits. It's a huge amount of data sets. So we really had a great time. So the data sets description, basically, it's a collaboration between the White House and between I don't know, the other parties and this data sets. But anyway, so we have taken this data sets. So they call into actions. They call into action looking for developers to develop AI applications on this data sets, or doing or making any sense of this data sets. So basically, what, and there's a there is also, if you can win 1,000 per task, you can win that, you can get the award. And basically, we took this data sets, and this data sets is already provided in JSON. So it's already mixed with the code in JSONs. So that's when it comes to cleaning and analyzing. We have to do the cleaning and analyzing. So we need to get away from the codes. We need to have the text, and also we need to run Python scripts to make, I mean, to order the outputs. For example, I need to have the title in each file. In each executed file, I need to have the title, and then under the title, I need to have the abstract, and then under the abstract, I need to have the full body of the articles, and that goes for each file. It can be processed for each file. So we worked on that. Let me share with you the projects. So you can go ahead and, if you are interested about that project, let me go back. Do some reading. I really cannot cover talking about everything. But again, what we have developed, basically. So the objective, we aim to assist medical professionals to isolate their work to fight COVID-19. This will help reduce research time for the medical professional time by accessing a wider range of research resources, all the resources they need in one place, in one environment. So we have took the data sets, and then once we took the data sets, and then it comes to data analysis and cleaning the data from JSON code. based on text only. And then we have only took, I think, 1,900, almost 2,000 articles. We have not developed, we have not run our assets in all of the, we have not took advantage for all of the articles. We just took 2,000 articles, and then we did our experiment on the 2,000 articles. So, and then what we have done basically, as I explained, we run a simple Python scripts to extract the title, and then under that abstract, and then full text articles. And that's the Python scripts. If you would like to to use it to run it on your local or on the Jupyter remotely. So basically, after we clean the data and then we have the files, think about it, 2,000 files. It's already clean, it's already ready. Then we have to go ahead and feed it to Watson Discovery. And Watson Discovery, smart AI's search engine, we have feed like 9,100 articles inside Watson Discovery. Once we finish feeding the Watson Discovery, and then we have there is some configuration that you have to do with simple clicks. You can apply the machine learning on the articles, and then we have to train the machine learning based on the user expected. We have to give Watson Discovery some questions. We have to make some questions that maybe the user or the researcher or the doctor, they will have to ask the applications. So we have to make some expectations. What are the questions that maybe going to be asked from the users? So, and because of the articles is really related to medical stuff, I don't understand I couldn't really build the questions. I don't understand the articles. So we did, I think we did 1,000. We did 1,000 queries about the articles. And then we trained the Watson machine learning based on questions, based on queries. And then Watson Discovery will give us answers as it's like the first process. And then we have to do a lot of reading and see which answer is more relevant to the questions. So we've done a lot of work on that projects. We had a really great time on this projects last year, and it's open source data sets. And then finally, after we finish the Watson Discovery, after we rate, the relevant answer to the question, to the query that we're training, after we've done all of that, then it comes to the part of doing integrations with Watson Assistants, with Watson Discovery, so we can build the applications as a chatbot, as NLP platforms. So this is the final outputs where when the user can ask questions about, for example, Puka virus, then it gives 3 different responses about the Puka virus, and think about it, a huge amount of articles. So it gives very small answers on that. So to conclude, this conversation AI chatbot in the research community can be beneficial to help scientists and doctors reducing time and isolating their work to fight back COVID-19. I think we are almost covered this done now. So that was, a year ago. So now we are moving to containers technologies. So as we can see, this is how it looks like, the containers in a real world scenario, right? The shipping, this is how it looks like in the world scenarios. But in the IT industry and application software, a container is a standard unit of software that packages your code and all the dependencies, so the application runs quickly and reliable from one computing environment to another. So containers can be moved between environments and run without changes. Also, containers work by isolating the differences between applications inside the containers so that everything outside the container can be standardized. So why containers? Containers are changing the economics of delivery today. Most enterprises now are moving to containerize their applications using the Kubernetes. I don't know if you guys heard about Kubernetes. Please, guys, if you can send me in the chat if you know about Kubernetes and about containers technology. I just want to understand. So so now containers allow developers to package up their applications with all of the parts it needs, such as libraries, other dependencies. So Agile, using containers, companies actually can develop and run applications separately from their infrastructures. This can allow them to deploy new softwares more quickly. Also, when we think about digital transformations, containers are becoming a key tool for digital transformations. Continuously deployment, continuously delivery. Every deployment process will be automated with continuously. For example, if you do any changes or commit any changes in your code, then the container will automatically detect any changes in your database, in your code base, and continue the deployment of process by rollbacks, if you have rollbacks, and that can be done in a second because it's automation process. Separately of concern, management, microservices, and resources isolations. Your resources, your applications, database, everything is isolations, resources, utilizations. So why containers? So many years ago, there was the deployment process, was traditional deployment, virtualized deployment, container deployment. Now we are in a world of container deployment. So every company is in IT's an organization now, they're using containers technologies. So basically the problem with the traditional deployment, organizations run applications on a physical surface. There is no way to define resources boundary for applications and in a physical server, and that can cause resources distribution issues. For example, if multiple applications run on a physical server, one application would take the most resources and the other application would be less performing. And also virtualizations deployment, basically, if you think about, you have two applications, Python A and Python B, in this boundary. If you do any change for example, in Python A, in the resources or in the libraries, then it will affect the Python B, right? It will affect the Python B, and that's because it's not isolation. So now containers, basically, when you look at the containers, are similar to virtual machines, but they have relaxed isolations, which is relaxed isolations. Also, containers consist of lightweight, which is it doesn't handle the image, the operating system file systems. Containers doesn't handle the operating system file systems or images. Because the container has its own file systems, CPU, memory, process, and space, and so on. And think about the containers, basically, it's just like a small unit running on the cloud, small environment, independent, running on the cloud. And that's how it's developed, and that's how it's started, the generation, how it started from there. Okay, monolithic, I don't know what time, I think I spent a lot of times. Okay. We need to move fast. Okay, monolithic architectures and microservices architectures. Basically, when we think about monolithic architectures, is a single unit, which is, and microservices like architectures breaks it down into a collection of smaller independent units. As you can see, these units carry out every application process as a separated service. So all the services have their own logic and the database as well. Docker. Well, Docker is a tool which is, Docker comes in 2015, I guess, and it's the first machine Docker engines comes to the world. Docker is a tool designed to make it easier to create, deploy, and run applications by using containers. Again, containers allow developers to package up applications with all of the parts it needs, such as libraries and other dependencies, and deploy it as a one package. This is how you can, basically, when you finish with your code, you write your front end, your back end, along with the database, all in one package, and all the dependencies, the libraries, and your local. And then that's when it comes to Docker. You need to have skills on how to write a Docker instructions, which is you need to specify every libraries and dependencies that you have used in your applications, and just to specify it once, and write the instruction from the Docker, and then just Docker build, and you build the image. And once you build the image for your applications, and then now you have the freedom to ship your image anywhere in the world. You can ship it, and it can be running easily. No need to to run it on your local. It can be shipped. It can be running in any environment, anywhere, in any containers. And then that's how we can, once you build the image, and then you just ship it inside the containers, and then just run and swim. Kubernetes. Well, Kubernetes is basically, you can call it tools, you can call it a platform, but Kubernetes was developed by communities such as open source, Google, IBM, Red Hat. So they developed this open source technology. So it's open source for managing containerized workloads and services. It has a large and growing ecosystem. And what does container do? Can define application types, can deploy code. So today, now we are going to use Kubernetes and how to deploy applications. It can do management. You can manage your application in a second. Machine management can do all of the configurations, service delivery, and storage, orchestration, self-healing, automations, and that's it. The architectures. If you are really familiar with Kubernetes and you want to have a future with the Kubernetes, it's very easy to use, basically. This is our just very important components if you are interested to use Kubernetes. Something we call clusters. Clusters basically is a set of machine. Sometimes we call it nodes. And then we have something that's called pod. Pod is basically just the smallest unit in Kubernetes 8, version 8. And each pod, usually 1 containers per pod. That's what is usually. But you can run more containers in 1 single pod. That's okay. But it depends on how you want your architecture. Each pod is given unique IP address. Each pod has given a unique IP address. And then we have something that's called, very important, kubelet. Kubelet, which is the communication between the masters, within the master nodes, is for to communicate with the master nodes. As you can see, this is the master nodes, which has the 4 components and master nodes, and this is the worker nodes. So kubelet is you communicate the worker nodes with the master nodes. So is the platform between them. Is the middleware. It's the middleware between worker nodes and master nodes. And then we have something it's called kubeproxy, runs on each node to handle the networking services. And then we have something that's called scheduler, which is responsible for assigning pods to nodes. The scheduler is responsible for the automation process. Think about, let's say you have 3 worker nodes, and you have, let's say in a large enterprise scenarios, you have 1,000 applications, and you have 3 worker nodes. Let's say the lab architecture you have 3 worker nodes. Of course, you can have 100 worker nodes, but let's say 3 worker nodes. Now we just only have 2. Let's say 3 worker nodes. And then you have 1,000 applications. And then you want to manage. Okay, I want 100 applications to be automated and running in worker node 1. And then 200, I want to be running on worker 2. And then the rest running on the worker 3. And that can be, the scheduler can manage and handle this, the response between the communications. And then we have control managers, which is responsible for taking the actions and watching the state of the system, watching the status, and so on. Red Hat. All right, Red Hat. Let's talk about Red Hat OpenShift. Red Hat OpenShift is an international software company. It's most known for their enterprise operating system. Red Hat Enterprise Linux basically operates on professional open source business models and sells subscription-based customer support. So IBM bought Red Hat for 34 billions. The deal was not the Red Hat, but the Openshift basically is a part of Openshift. Was closed in 2019. So Red Hat Openshift is a platform for deploying cloud-native microservices-based application. It can be hosted locally on the public cloud, support any programming languages, support any open source projects. There's so many open source projects that you can use for your development. Built on Kubernetes, deploy on Red Hat Enterprise Linux. Openshift overview. Well, it's developer workflows, access to services, automation processing for your applications, makes your life easier. Think about if your manager asks you to, to do some updating for, let's say, 100 applications. How long does it take you to do that? Well, it will take you a week, 2 weeks, 3 weeks to do that, or maybe a month, 2 months. Well, now with the Red Hat OpenShift, everything is automation. Everything can be done in a second. The architecture for OpenShift components is very similar to the Kubernetes, as I just talked about. All right, this is what we're gonna have. We have a lab object detections. It's already developed with Python TensorFlow, and it's already built in a Docker, and the image is up and running and published in a Docker Hub. So we are going to take this image, and then we're just going to ship it inside those containers. So as you can see, this is each unit right there is a container, basically, is a containers. And this is basically this is just like image. This is like image registry, right? You know, the image registry can be written in the Python. I think the most famous images registry written in the Python. So the image registry can be written in Python. So this is like image registry. How many image registry we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 image registries. And each 10 image registry, we have, I think, 10 containers, right? So now we are going to deploy our applications in one of those containers. Let's choose the first image in one of those containers. Maybe the first container right there inside, it has 5, 6, 7 pods. I'm not sure. So that's how it works, and that's how we're going to use the Kubernetes, which is the core of OpenShift, and using the OpenShift high levels programming. I mean, CLI commands has been developed, and it's going to be running on Ibm Cloud. Okay, all of this process on Ibm Cloud. So basically, the application architectures we have. The Pythons. I will navigate go through the code just a little bit. Okay, so we're going to go to the hands-on. Please sign up with I already shared with you. I hope you guys ready to follow along with me. I'm not sure. I want to see the chat. Where is the chat? Am I? Do you guys hear me? What? Is it half of the time? Yes, I think he has. What? Can I have more time, or I think the hands-on maybe takes 15 minutes. We're not going to take that long. Is that okay? Are you guys ready? Okay, let's jump into the hands-on. Yes, I need 15 minutes, I guess. We're just gonna do some experiment about the lab. Just gonna test the lab. All right. Well, okay, we have opened the lab already. So please, for anyone who has not signed, you can go ahead and sign. And to access the lab, it's right there. Okay. Now we need to go back to, okay, let me log in again. No, we need to IBM Cloud. Okay, if you have registered and you have access to the lab, this is where you can let me go to the dashboard first. Then Openshift, we will open the Openshift. And then once you open the Openshift cluster, Openshift Web Console. And then once you open that, now we have administration and developer. We need to be as in administration mode. We need to create projects first. And then we will navigate to developer. But let me share with you the hands-on that I just shared with you. Basically, if you can log in, it will. You can. You need to have. You need to have account with the Cognitive class. Basically, you can assign with Cognitive class using your Google account or your GitHub account or LinkedIn account. You can access to it. And then once you access to it, these are the steps that we're going to walk you through. So deploy AI microservices on Kubernetes. So the applications basically it has a REST APIs, a backend and front end, and we are going to first deploy the REST APIs backend, and then we're going to connect it with the front end, and then we will test both of them. And the image, no, we need to go to step. No, we have 11 steps, but I think we need to jump to. So it should take you about 13 minutes, but I think we did only 15 minutes. So let's continue. Okay, so number 4. I think step number 5, yes. What is the image? This is the Docker image. It's already published. If you look for the Docker Hub, if you look for this image, it's already published on the Docker Hub. It's already in Docker Hub. It's published 6 days ago, last update for this image. Now we're going to take this image and deploy it. So the first, if you want to see the code about the applications, oops. Yeah, let me just make this small. I think maybe step number 4. Step number 4. Yeah, this is what the code. This is the back and the front. You can clone this code. If you want to run it on your local, you can do that. But it has the structure, so you can run it on your local. If you don't want to run it on Openshift, you can just clone the projects and then cd move to the directory of the projects. It's called max object detectors, and then you need to have Node.js install npm, and then just run that. Excuse me. But you need to run the backend first before you run the front. So this is, I guess, the front. This is the back. This is the back. Also, you need to have a Docker install on your local to use Docker run, because it's already developed in the Docker. You need to have a Docker as well. You need to run this first, and then you can run the front end. So basically, so this code basically build build a Docker image of object detector max models, deploy a deep learning model with the REST endpoints, recognize objects in the image, and that's how we can extract the value in images using the AI, and run a web applications that use the model's REST APIs. So it's already developed in TensorFlow. We have Ibm developers. Okay, so let me share with you the code, maybe if you are not able to. I think you're right there. Oh, that's okay. I'll share it later. Now let's go back to Openshift. Back to the slide. And let's customize this a little bit. Okay. Good. You guys can see? Okay. Well, that's not Openshift. What is Openshift? Gosh. Where is Openshift? Got a lot of Windows open in front of me. Did I close the window? Yep, right there. Okay. So we need to create the projects first. We need to create a projects. We need to be as administration. Go to the projects, and then create a projects. We can call it use case, and then we don't need to add description or anything. Okay, then we navigate back to the developer mode. And then you can, in the topology, you can deploy your application from a GitHub. You can deploy application from a Docker image, from a container image, from a Docker file, from YAML, database, and any. But we're going to deploy our application from a Docker, from a container image. So now we need to put the name of the image, which is, I believe, I did copy the image. Step number 5. Yes, right there. Step number 5, we need to copy the image. Now we can copy the image and do research. We have to do research. Okay, now it's automatically find the application name and all of that stuff. So the routing, it's already checked, because we need to access to the route so we can connect to the backend and connect it with the front end. And then health check, we can check that for that. And then deployment, and then that's in the deployment we need to add the environment variables, which is to make call between the backend and the front. So we need to go back and then go to step number 6, I guess. No, step number 5. Right down. Yeah, you need to add this environment variables with value true to make call between the back and the front. Make sure there is no space. Okay, sometimes you have space. I always face issue. So let me make sure there is no space. Okay, and then just give a value true. Not sure if it's capital. Okay, we need to check for the scale. You can scale your application replicates more than pods if you want to. Resource limits. We need to add, I believe as a default, we need to add 2 requests and 2 limits. So we can do it as a default, but you can keep it. You cannot. You can leave it not to add any. But let's do the same. Okay, and that's all we're doing. Now we head to the create now. Okay, awesome. Now the applications, it's running on Openshift in Ibm Cloud. and it takes a little bit to get deployed. Just wait a little bit. And this is basically when the route, because you check the box, so it's a route, it's enabled. That's it. Give it just some time and it will get deployed. We have some images that has different objects, so we want to extract the value from using the object detections from the images that we're going to test to. It's ready. So we have two. What's right? You also can check for the YAML file. You want to see the process and how it goes. It's pending. Why is it taking too long? Okay, there we go. I think my internet is slow or something. Okay, let's go to the second part. All right, now we can access to the route once it's deployed. And we can test our model using some images. Right there, we can get paused. Let's try it out. Now we need to try it out. We can choose the image. I think, on the desktop backgrounds, I have two images. That's a little child and the dog. Let me just now, once we select the image, we can execute. I hope it makes predictions, person and dog, and tell me the accuracy percentages. Okay, now we have person and dog, and that's the result from JSON. The result from JSON, person and dog. The accuracy probability is 0.95, and then for the dog, it's 0.88. Awesome. All right, let's go and try to access to the front end, which is, I believe that you just need, in the same route, because we have already called we specify in the environment, and then the parameters, we specify the environment, and then we give a value as a true. So it's already, the APIs makes a call. So you just need to add in the route at the end, you need just to add apps. That's how we can, oops, not, I think apps or app, I'm not sure. Need to double check. Yeah, app. And that's basically the front end. So you can test the object detections using your webcam. You can have different objects and try to test the the model, see if it makes to make prediction or not. Let's test it on this car and airplane. Hit submit. So now we have two labels. If we decrease the probabilities, it just gives more labels on that. But as a default is a 50. That's how the app works. So we have airplane and cars, and yeah, I think that's it. Let me just to summarize. What is the steps? Oh, basically, and also using the CLI. Using the CLI, you can use the CLI to work with Openshift. If you are interested to work with Openshift, you need to open the terminal. But we're not going to do the CLI one. I can do the CLI, but it's going to take times to do that. You can do the CLI. If you guys are interested to do the CLI, command line interface, you can deploy the same application, the same process that I did right now using the web cancels by putting the image, doing some research, doing some clicks. You can do the same steps using the command lines. And basically, I can walk you through it, but I'm not going to do it. Not big, not big, small. What happened to window? Okay, all right. You can see OC versions to check for the Openshift versions, OC projects to see how many projects you have, which projects versions. And then we just OC, which is a Openshift command line tools. That's what is OC, it's open source. So, and then new app to deploy, and then you just put //search, and then you put the name of the Docker. And then if you want to display, and then this is the result, will, you know, because it's going to do some research, search, so it will display these outputs. And then OC new apps, that's how you deploy, and you put the name, OC new apps, and you put the name as it's given below in step 5, the name of the image, and then it will get deployed. And then once it gets deployed, you need to expose and create a route. And then you need to set the environment, deployment config, because as we talked about, to make a call between the REST APIs back and front. And then just to check the status. And then OC expose, because you need to have the route. And then OC get route max to get the route. And then it will be automatically displayed in your cluster. What is my cluster? It will be automatically displayed here because you're used to the CLI. But I think that's all we have for you. But let me go back to my slides. Where's my slides? I think we have other stuff to share with you. All right, Call for Code. Call for Code is amazing. Is foundation by Linux. It's an open source challenging initiatives. If you're looking, trying to make an impact to the world and you know, to the disaster situation or water or any other stuff, you can, you know, come up with the solutions, form a teams. And it's for everybody, students, professionals, anybody can participate in this open source initiatives worldwide. And it's amazing. Last year I participated in Call for Code, and it was amazing. Really was amazing. I had a fun. I learned a lot from my contributions. I collaborated with other people from different culture, from different area, from different. It was amazing. Really was amazing. So that's what I just want to, if you want to look at for Call for Code, just search for Call for Code 2021. And there is a starter kit. Starter kits, basically, there's some different use cases about different industries, so you can look at it just to enable you to get started. And this is some useful resources if you're looking to be certified or you want to learn about open source, which is a Red Hat company. You can go ahead to these resources. Let me share that with you. And also Watson Assistant, just like very basic about building your chatbot, first your chatbot. And also design thinking courses, design thinking, really good one, I recommend it. And then Watson Learning Path. That's all I have for you. I really enjoy it. Thank you so much for inviting me for this such a beautiful conference. How am I gonna go back to? Okay, right. Where is? Oh my God, I'm done. Where's the meeting? Yep, right there. Amazing. I hope you guys, I can give maybe 3 minutes for questions. If you have any questions. If you have any question, please ask.
Anyone have any question, you can share in the chat box.
Hello?
Yes.
Hello?
Anyone have a
Yes.
question, please ask.
Yes. Can you please type your question? I think he's not able to hear us.
Okay. I think it was just a suggestion.
All right. So thank you so much for attending with us today for the conference and for the workshop. I hope you find this useful. And please contact me on LinkedIn, Twitter, email me if you need any resources, if you need any maybe collaborations, let me know. And that's it. Thank you so much and have a brilliant day, everyone.
So thank you, everyone. I think Mr. Muwaffaq, he's not able to hear us. Can you hear us now, Mr. Muwaffaq? Okay. So he's going to share with us his information on Twitter and other informations if you want to contact him. Thank you for your attendance. And can you hear me, Mr. Muwaffaq? I don't think so.
No, I cannot hear you. I can see your text, but I cannot really hear you.
Yeah.
I really don't know. Can you talk again, maybe? Talk again?
How about now? Can you hear me?
No, I don't know what's happening. That's okay.
So I would like to thank Mr. Muwaffaq and everyone who have attended.
I cannot hear you, Doctor. Sorry about that. Really sorry.
Okay.
Thank you for inviting me, and I hope you guys enjoyed. Thanks.
Thank you, everyone. So please, if you did not write your name in the attendance sheet, please go to the link now and add your name and information. And it was lovely to have all of you, and I appreciate your time.